In this video, I'll be going over the 3D modeling processes and key features of human forms, creature forms, buildings, and props. We will look at overall terms for 3D modeling and what key characteristics need to be kept in mind for different modeling processes. We will then compare human and creature modeling to building and prop modeling, including the processes behind these practices and reasons for said practices. Basic terms of 3D modeling. Faces/polygons/polys. These are the outside layer of a model that make up its entirety, connected together at the edges and vertexes. Faces should be 3 to 4-sided, preferably 4-sided if you're creating your model for use in a game engine. These 4-sided faces are called quads, and 3-sided faces are called tris. Edges. These are the sides of a face, the lines that go around it and create the wireframe of a model. Edges are essentially the lines all over a model that determine how the shape of that model looks. Vertexes. Vertexes are the corners of a face, the points at which the edges meet. N-gons. N-gons are polygons with more than 4 edges. These should be avoided at all costs when planning to use your model for a game engine. However, N-gons could be used in hidden areas if you plan to animate your model for a video. There should be very few, if not 0, N-gons in any model of a good standard. EdgeLoops. These are a set of edges that connect at the vertexes to form a loop, as the name suggests. These are sometimes called spans in the animation industry. EdgeFlow. This is a word used to describe the direction in which edges connect together. It describes how a model has its shape and how it will move and deform when animating. Poles. These are vertexes where 5 or more edges meet at a point. These are most often used to redirect the edge flow of a model so that it deforms properly when animating. You want to try to avoid poles with 5 or more edges leading into them, as many game engines and renderers do not like this type of pole. Deformation/deformation. Deformation is the way a model changes shape when you move it during the animation process. Speaking on only how the modeling process affects deformation, the edge flow and placement of edge loops on your model will be the key factors of how your model deforms, as well as proper topology. Topology. This is your model's structure, the way the faces, edges, and vertexes are laid out all over the model. Having good topology is a must for your model, especially in areas that will have a high amount of deformation, such as the face and joints for humans and creatures. The topology of 2 models can be completely different but look the exact same when rendering an image. UVs/UV map. A UV map is basically your 3D model folded out and laid flat so that textures can be applied properly to it. Having a good UV map is essential to any model that you plan to use in professional rendering or a game engine, as not having a good UV map will make texturing a model and detailing it with a displacement map very difficult. As a side note, it's much easier to UV map an object made out of quads than tris. References. When creating professional 3D models for anything, having design references always helps. Always try to have at least front and side view references for your model, if not front, side, and top, or front, side, top, and back. This lets you basically trace out what you're trying to create as a 3D model, and then go in and refine it to exactly how you imagine it in a 3D space. I'll now move on to describing the 4 different forms which I mentioned earlier: humans, creatures, buildings, and props. Human forms. You want to start with cylinders, because these mimic the organic shapes and edge flow of a human body. The edge flow of a human body allows for deformation in certain areas where some parts of the body become more rigid and some parts of the body have much more movement to them. For example, the edge flow of the lower back and butt needs to have a turn in it that allows the edges to roll down the legs and wrap back around them so that you have a proper corner of deformation where the butt is. Topology of the human form is very important in areas such as the face, joints, and body of a person. You want to have a high poly count in areas with high deformation such as the joints, and proper edge flow and edge loops on areas such as the face, because this area of the body will have the highest deformation of all. Examples of where the edge flow of a person needs to be changed are the butt and the shoulders. These are areas where you'll want to use poles to redirect the edge flow. For example, where the leg connects to the hip, you need to have an edge loop that wraps around the top of the leg but also connects to the pelvis and the side of the body. You'd want to use a pole to redirect the edge flow on areas such as the side of the hip or the butt, as this doesn't have very high deformation, so it won't be affected too badly. Another reason why we redirect edge flow is so that edge loops are now at different angles and flow around the curve of the organic shapes of the body, which allows for good deformation later on when we're animating and deforming the body. The facial topology of your human model is very, very important. You want to have edge loops around the eyes and mouth of a person. This will be important for deformation later. The curves of a human face are very interesting and very difficult to get right. You will be using lots of poles to redirect the edge flow in areas which aren't very highly deformed, such as the sides of the nose and inner areas of the cheek. Move your face around and see just how many times it contorts and changes shape. Having a high poly count on the face is generally considered good practice, as we need to have those shapes, curves, and edges which allow us to have that deformation to create motion in our faces. When creating human form, the standard is to create the topology as you're creating the model itself, or at least do something to aid in topology making later. This can include adding edge loops as you're modeling, or creating the areas of the body separately and then adding them together by using poles to redirect proper edge flow. It's best to use quads when modeling for a human form. This allows for better deformation later. Sometimes tries are okay to use in areas that won't deform much or will be hidden, or if it's absolutely necessary to use a try to avoid having an end gone or a more than 5-pointed pole. Creature form. Creature forms are largely the same as human forms, but with topology in different places and areas where you want to focus on more than human forms. When modeling a creature, the silhouettes are very important. Having a good silhouette that mimics the creature and style you're trying to create is very important, as it will give you a good base mesh. When creating creature forms, blocking out and creating a basic base mesh and then going back and retopologizing it is common, but you should still be trying to practice going in and creating the topology as you're creating the model, instead of going back afterwards and redoing it. This saves you a lot of time and makes it so you don't have to work as much later. Creating creature forms is very similar to creating human forms, but you need to make sure it makes anatomical sense and will deform properly after modeling. For example, you need to make sure that you have edge flow and edge loops that make sense for the area. Don't treat the leg of a dog like the shoulder of a human. The edge flow and loops need to be different to accommodate for the different anatomy. Creatures and animals have different bone structures than humans. For example, the ankle of an animal with digitigrade legs is higher and creates this backwards shape of the leg, and it makes it look as if it has 2 knees to allow for more power and speed, but aren't as stable as human legs that have 2 points on the ground compared to the 1 of digitigrade legs. This needs to be reflected in the topology of your model by having the appropriate edge loops and topology in places like the joints and connecting sections of your creatures. The main thing to remember for human and creature modeling is that these are dynamic models. They'll need to deform, stretch, and change when moving about and animating them. Buildings and props. In contrast to human and creature models, which are dynamic, these types of models are static and generally less detailed and don't move. When modeling buildings and props, you want to focus more on the hard edges of the model and the overall shape of it, because you probably won't be deforming it much at all. With building and prop modeling, edge loops aren't going to be in places like the joints, because there probably won't be joints. Edge loops need to be in areas with hard edges. As edge loops help define hard edges on high poly models, the more edge loops that wrap around a part of a shape, the more sharp the edge of the model will be. This isn't the case for a lot of low poly models, but if you're aiming to model in high poly, you want to have a high number of edge loops around hard edges. Buildings and props are generally lower poly than human and creature models. This is because they won't be looked at as much or as up close as human and creature models generally are, but they often still need to be to a good standard of detail so that they make sense in context. If needed, tries can be used excessively when modeling buildings and props. Creating a model from tries will generally stop deformations from happening as much in areas that need to stay rigid. While not as important for models that are only going to be used for rendering, good topology is still required if you plan to use a model in a game engine. This is because applying a good quality texture and displacement map later on will be very difficult if you don't have good topology which allows you to have a good UV unwrap. Overall, having good topology and placement of edge loops is very important for all types of modeling. This is because if you don't have a quality UV unwrap, you will not have a very nice looking model when it's textured and displacement mapped. In conclusion, when modeling either humans or creatures or buildings and props, the main thing to remember is the difference in detail levels and approach. When approaching humans and creatures, you need to be thinking with curves and deformation in mind for the later rigging and animation processes. In contrast, when modeling for buildings and props, you generally don't need to worry as much about edge flow, but good topology is still very important to have if you want to use high quality textures and displacement maps later on in rendering or in a game engine. I hope this video helped you understand modeling for organic forms such as humans and creatures versus modeling for non-organic forms such as buildings and props. Thank you very much for watching.